Dear students, I am Dr. Anima Upadhyay, and in my chemistry lecture series, today I will start a new topic, that is electrochemistry. So in the electrochemistry, we should first understand what electrochemistry stands for. Electrochemistry is a branch of chemistry that deals with the electrical energy and the chemical change. We can also say that the electrochemistry is all about the chemical reactions that takes place in a solution at the interface of an electrode and electrolyte. These chemical reactions are responsible for the flow of electrons, which in turn produces electricity. So, the generation of electricity through the redox reactions are studied under electrochemistry. When we talk about the electrochemistry, it is about the passing of current through an electrolyte which dissociates the electrolyte into ions. So we can say that it is the electrolysis of the electrolyte that dissociates to produce ions, and these ions moves towards one or the other electrode, resulting into the passage of electric current. The device which is employed to bring about the electrolysis, in which the chemical reactions takes place, is called electrochemical cell. So let us first talk about the electrochemical cells. As I explained, the device in which the electrolysis takes place as a result of passage of current is called electrochemical cell. So we can say that the components of electrochemical cells are the electrodes and the electrolyte. The electrolyte is an aqueous solution of a substance which dissociates to produce ions. And the electrodes are the metal strips or the metal wires which are immersed in the electrolyte. On these electrodes, the chemical reactions occurs. These electrodes can be further divided into anode and cathode. The anode is the electrode where oxidation takes place, and the cathode is the electrode where reduction takes place, irrespective of the type of cell. In the oxidation reaction, the electrons are liberated, or it is the loss of electrons. The electrode, that is the anode, dissolves to produce metal ions with the loss of electrons. Whereas in the reduction, the metal ions of the electrolyte gains the electrons and get reduced to metal at the cathode, and this process is called reduction. The electrolytes are the substances which conduct electricity in their aqueous solutions. On passing the electric current, the electrolytes dissociates into ions. These ions have different charge. The positively charged ions are called cations and the negative charged ions are called anions. These ions moves towards oppositely charged electrodes and is responsible for the conduction of electricity. However, the electrolyte as a whole is electrically neutral. The examples of electrolytes are common. The acids such as sulfuric acid, H2SO4, hydrochloric acid, HCl, bases such as sodium hydroxide, NaOH, potassium hydroxide, KOH, and salts such as the common salt, sodium chloride, NaCl, potassium chloride, KCl are all the examples of electrolytes. We can classify the electrolytes on the basis of their ionization. The electrolytes which ionizes completely are called strong electrolytes, whereas the partially ionized electrolytes are called weak electrolytes. The examples of strong electrolytes are hydrochloric acid, nitric acid, sodium hydroxide, potassium chloride, etc. The examples of weak electrolytes are formic acid, ammonium hydroxide, acetic acid, etc. These electrolytes dissociates to produce positive ions, that is cations, and negative ions, that is anions. The positive ions moves towards the cathode and the examples are zinc 2 positive, aluminium 3 positive and potassium. Negative ions moves towards the anode and the examples are acetate ions, formate ions, etc. Now let us discuss about the electrochemical cells. The electrochemical cells are the devices in which the conversion of chemical into electrical energy or vice versa is carried out. These electrochemical cells are of two types, electrolytic cell and galvanic cell. The electrolytic cell is a device that converts electrical energy into chemical energy by the passage of electricity. And the examples of electrolytic cell are Nelson's cell, Herring-Bloom cell, and all those cells in which a metal is coated on the other metal. That is, for the metal coating cells we use electrolytic cells. Whereas the galvanic cell is one that converts chemical energy into electrical energy by spontaneous redox reactions. And the examples of galvanic cells are Daniell cell, which is a classical example of galvanic cell. The Dry cell or the Laclanche cell is an example of galvanic cell. Let us differentiate the electrolytic cell with the galvanic cell. An electrolytic cell is one where the reactions are brought about by an external source of current. whereas the galvanic cell is a device where the spontaneous redox reactions produces the flow of current. The electrolytic cell is the one where the electrical energy is converted in chemical energy, whereas the galvanic cell is the one where chemical energy is converted into electrical energy. The cathode is negative and anode is positive in the electrolytic cell, whereas in the galvanic cell the cathode is positive and anode is negative. In the electrolytic cell, the electrodes are immersed in the same electrolyte is used in the electrolytic cell. In the galvanic cell, the electrodes are immersed in different electrolytes. That is, the electrodes are immersed in the solution of its own ions, such as copper electrode is immersed in copper sulfate ions, zinc is immersed in zinc sulfate ions, and so on. In the electrolytic cell, the salt bridge is not required, but in the galvanic cell, the salt bridge is mandatory. The examples of electrolytic cell I have already given. Again, I'll repeat, it is Nelson's cell. All the secondary batteries under the charging condition acts as electrolytic cell. And examples of galvanic cell are Daniell cell. All the secondary batteries under the discharging conditions acts as galvanic cell. The construction and working of a galvanic cell I have explained in my YouTube video on the electrochemical corrosion. So please watch the video if you want to understand the construction and the working of a galvanic cell. I have explained there it in detail. The other topics on the electrochemistry I'll be continuing in my upcoming videos. Thank you.